Detecting label errors using pre-trained language models. Label errors. Every dataset has them. Good thing all the pre-trained models we use these days are robust. There's endless literature on learning with label noise. So we're good, right? Well, we're pretty good at learning with label noise. Errors in validation and test sets and on benchmarks are another question. What kind of noise are we talking about? Most studies test their models on synthetic noise, like perturbing labels in a uniform or class-based method. Easy to reproduce, but is it actually realistic? What are our contributions? Pre-trained language models can find label errors in real datasets in the wild. We did an expensive human evaluation of this method. But we also have a way for you to benchmark methods addressing label errors. And that way is a more realistic and more challenging way to evaluate model robustness to label errors. We call it human-originated noise. Finally, we show that finding these errors and fixing them matters, especially when you evaluate with label errors. So first, pre-trained models do find label errors. Fine-tune a model on a task, then take some out of sample points like a validation set. Run the model on those items and sort by descending value of loss. As you go down that list, you find lots of label errors. What was our ground truth for this task? We sent every point on this plot to 5 Amazon Mechanical Turk workers for a re-evaluation. It's a lot of work, and for large datasets, you aren't going to be able to relabel every single point. That's why people evaluate their models on synthetic noise. What is synthetic noise? Say you have a part of speech labeling task. I'm looking forward to advice. The correct label is a noun. If you want to simulate an error, you might change the label to another class at random, like an adjective. But this isn't really hard for any model. Advice is obviously not an adjective. So what is realistic? Many datasets are crowdsourced, so you can actually have data on what humans get right and get wrong. Here, 2 labelers maybe thought advice was the verb advise. Selecting one of those labels would be a more realistic and challenging error. If you add noise to a dataset with synthetic noise, the true underlying performance of the model, shown in the blue line, does pretty well. Yeah, add 10, 15, 20% noise. The model knows what it's doing. When you add human-originated noise, this harder, more challenging type of noise we introduce, the true performance starts to drop. The model is not robust to this more realistic type of noise. Here are the distributions of losses when evaluated on different types of noise. Uniform and class-based noise in purple are super high loss. They're way out to the right and easy to pick out. Human-originated noise, shown in orange and red, are way harder to pick out, and they look a lot more like the correct data points. Finally, we show that if you use our method to go clean up label errors, it matters. The cleanup validation set will select a different set of hyperparameters, which then changes downstream model performance. And the performance you report is also more accurate if you're reporting on corrected test data. If you're curious for more, stop by our poster. See you in Abu Dhabi.